Oh, you're on Neptune?
What'd you guys get for Jupiter?
4,380.
Okay.
Uranus.
What am I going to label it as? Is it years? Is it days? Is it hours? What is it? Days.
We should try and go down to how many seconds it takes.
You could do that. You could figure it out, couldn't you?
But then you'd have to do like the 60 minutes in an hour.
What if I said, Elena, how many hours would it take? How would you figure that out? I'm not going to make you do it, but how would you figure it out?
The number we got divided by 24.
The number we got divided by 24.
It's 24 hours a day.
Actually, it would be time 24 because we have to figure out how many hours. Each of these days times 24. And then we have to do times what? 60. Figure out how many minutes. Using this method, you could actually find out how many years, how many minutes you've been alive.
I know, I've done
How many seconds you've been alive.
That's cool.
Yes, Jacob.
There's a cool fact. It says the density of water.
How do we know how
It says the density of water is 1 gram per cubic centimeter. Saturn would float because its density is less than the density of water Earth would sink.
That is cool. Very cool. You'd have to do the same method.
Earth would sink like a rock.
All right, so let's stop because I know some people have gotten all of the answers. If you didn't finish, we'll share our answers, okay? What did you get? Guys, enough. You're being rude. Voices are off. Raise your hand if you got an answer for Saturn. All right, Sydney, give us your answer.
10,585.
Is that what you guys got?
Yes.
I got
And I'm going to label it in
days.
days. Okay, what about Uranus? What did you get, Athena?
30,660 days.
You got it.
I ain't get that.
Okay, Trenton.
The computer.
What'd you get for Neptune?
60,245.
Everyone else get that? All right. It's okay if you didn't finish your multiplication. These are the correct number of days that each planet takes to orbit the sun. That means that if you lived on Neptune, 1 year would take 60,225 days. Where on Earth, we only take 365 days for a year. You would have very long years. Like someone said, you would never have a birthday on any of these planets. Right?
Except for Jupiter.
Or on, I guess you would have, yeah.
You would have one on Mars.
Just on, probably on Uranus and Neptune.
And Mars.
You could have a birthday.
And on Mars.
All right, so let's think about this now. Pretending that these numbers are in your chart, right? We changed them, we converted them, so they're no longer years, they're days. What do you notice, Jacob? Do you need to go back to your seat?
I just need an eraser.
Okay. I just want you to focus on this. What do you notice now? Now that these are in days and the inner planets are in days, what kinds of trends do you notice? It's a lot easier to compare now, isn't it? Rather than looking at 84 years and thinking, well, that seems bigger, but I don't really know how much bigger. What kind of trends do you notice about the period of a revolution on the outer planets versus the inner planets? What do you think, Victoria? Yeah, the outer planets have a much longer revolution. Logan?
For Uranus, I got 30,260.
Okay, you might have made a mistake in your multiplication. This is the answer I have too. So, like Victoria said, the outer planets have a longer revolution. Revolution meaning that they take longer to orbit the sun, right? They have a bigger orbit. Why do you think they take longer? Why do the outer planets take longer to circle the sun? Vicki?
They're farther from the sun.
Yes, they're farther from the sun, that their orbit is a lot bigger. Okay? So, in summary, what can you guys say about what's important to a chart? What do you think, now that we've done this and it's made it easier to compare, what do you think is important about using a chart? If you were making a chart for someone who didn't know what you were talking about, what would be important to your chart, Logan? Give me one thing.
It'd be important because it would be easier for the person to figure out how to
What would be important? Keeping your data the same, or your units the same. Vicki, what else? Keep it organized. Yeah, this is a really organized chart, isn't it? It's very easy for the reader to read and to understand. What else, Victoria?
I would say, since we've done this, I would say keeping it the same, not really changing it.
Keeping it the same, not really changing it. If I had made an adjustment to this chart, I probably would have written all the periods of revolution in days. I would have stuck to days for all of them, so that my reader could really compare it very easily. I think all the other ones are in the same unit, right? Yes.
It would have been really easy if they put them all in days to see how many years it was.
If they had put them all in days.
That would have been easy.
So now that we have them all in days, how would we figure out how many years? Mason? You would divide by 365. So if we did the inner planets, Victoria, and we did each of those in years, so say if we did Earth, it'd be 365 divided by 365, which is 1 year, right? That's 1 Earth year. If we did 59 divided by 365, that would mean that we were only getting about less than a quarter of a year. So that means that those inner planets, like Mercury, their years are like 3 of our months. They circle the Earth really quickly. It's pretty interesting, right?
We have a lot of New Year's.
They have a lot of New Years. Yeah, they do.
Whoa.
About every 3 months or so. Yes.
You said circle Earth.
Circles the sun, I'm sorry. Yes, Brenda.
That's pretty cool.
Yep. Oh yeah, actually that'll only be every 2 months, huh? So that's, a period of, that's rotation. No, so it would be 3 months. So what is rotation? What's the difference between revolution and rotation? This is going to be a question on your test, so make sure you know. The difference between rotation and revolution. Athena.
Rotation is where you spin, and then revolution is where you go in a circle.
Yes.
Like,
So the Earth is, and all the planets are spinning. Remember we saw that chart, and some of them were spinning so fast, and then some of them were spinning a little bit slower. So the Earth is it's spinning at the same time that it's revolving or orbiting around the sun. Okay, so don't get those confused. There's a difference between rotating on its axis. Yes, Elena.
On some planets, days are longer than years.
On some planets, days are longer than years. And why is that?
Because they spin slower.
They spin very, very slowly. I don't know. Are you sure about that?
Yeah.
Venus? Okay, let's look at Venus.
Mercury.
243 days. Oh yeah, to rotate. Yeah, that's really interesting. Did you know that off the top of your head, or did you look at the chart to figure that out?
No, well, I knew that I didn't know which planet, but I knew that one of the planets, or maybe 2 of the planets, that their day was longer than a year, but I didn't know which planet.
Okay, and we can easily look at the chart, right? That's another feature of a chart, that it makes it easy to just look at those 2 numbers, and we can see that the period of rotation is larger than the period of revolution. That's really interesting. A day on Venus takes 243 days, remember? So the morning would start one day, and it would take 243 days for it to be the next morning.
oh my god.
You would have already experienced a whole year
What time did it
by then. You would have had a birthday in the amount of time that changed a day.
You would have a lot of birthdays.
So so that would mean half,
One day.
100 and, let's see, if I divided 243 by 2, that'd be 120, it'd be 120 days of daylight, right, because half of our day is day and the other half is night. So 120 days of daylight and 120 days of nighttime. That would be so weird.
It'd
Yes.
be awesome.
So it's like their years are our days and our days are their year. Or
Their years, yes.
our
But they
days.
also have Venus almost has the same amount of days in a year.
Venus is the.
Logan, raise your hand if you have a comment.
So let's say they build the fastest
spaceship in the wall,
Yeah.
and it can get to a planet and get to Venus in exactly one day, if it was possible.
Okay.
So,
1 Earth day.
yeah, so technically, so you would be awake for at least, 200, no, yeah, 200.
Well, do you think if you lived on Venus, Logan, that you wouldn't sleep? Do you think your body would change? You would just probably sleep during the night. You would probably sleep during the daytime still, right?
Be like people living in Alaska.
Yeah.
Because
Because your body still needs sleep every 12 to 16 hours. Your body still needs sleep. So you'd still be on your own because you as a person, as a human being, you're still going to need sleep. You would just sleep during the day.
Yeah,
But if you tried to stay awake, you'd be awake for if you tried to stay awake during the day, you'd be awake for 120 days.
you'd have
And then you'd sleep for 129. Don't think that's going to be possible.
alive for 100.
All right, I want you guys to take this information and whatever planet you have, I want you, if you have an inner planet, you won't have done the math, but I want this to be on your poster, okay? Because that's going to be really cool when we present them. Today is the last day that you will be able to work on your projects. We might have a little time tomorrow, but try to get them almost done, okay? We can add like some finishing touches, but we want to present. We're going to share 3 tomorrow and 3 on Friday. Yes. Yes.
I can hold it. Never let you.
You want to get a laptop.
Oh, some people left their books and their pencils and their paper. Please come take your stuff and clean it up.
This is fun to watch.
Eunice,